First of all, I would like to introduce my title about low sedimentation rate of magnetorheological fluid. So what is magnetorheological fluid? Magnetorheological fluid is a smart material which consists of magnetic particles and carrier fluid. Well, the magnetic particles I have used in this project is Ci particles, carbonyl ion particles or carbonyl ion powder, and the carrier fluid is Caltex hydraulic oil 32. So the application of this MR fluid, magnetorheological fluid, was in suspension, brake, and clutch that is turned to active mode. The purpose I select this project because recently in manufacturing industry, there are a lot of shock absorber and brake system problems in material handling devices and machine moving parts. So for adapting rapid changing manufacturing system, magnetorheological fluid engineering device like damper are widely used today. So however, the disadvantage of magnetorheological fluid is it cannot help in statistically for long period of time due to magnetic particles, sedimentation, and density problems. In magnetorheological fluid, there consists of two things. There is two material. There is magnetic particles and the carrier fluid. So for the magnetic particles, I would like to use carbonyl ion powder. This is the carbonyl ion powder. Okay, as a magnetic particles, and the carrier fluid is Caltex hydraulic oil 32. So with these two material, we also need the tools to help our experiment. Then I will use these tools as a blade for stereo machine, and the rheometer machine to check the viscosity of the carrier fluid. Okay, besides that, I also have used the 10 milliliter syringe and 25 milliliter syringe to help my experiment. For the experiment, first I will put the carrier fluid. This is the carrier fluid, Caltex hydraulic oil 32, inside the container. Then I will put the carbonyl ion, Ci particle, Ci powder, magnetic particle into the container. So I will mix it and using this and go to the stereo machine to stir it uniformly. I would like to be using a stereo machine to stir the MR fluid, magnetorheological fluid, to make it in uniform stirring. So now we can see the fluid and the magnetic particles are separately, obviously. So they didn't mix well. So I will using the stir machine to make it mix well. And in stir machine, I'm using these tools to help me stir because it's got the blade there. And I will change the RPM to 800 for stir. So now I start to stir the MR fluid with using RPM 800. And I will stir the material for around 5 minutes. After stirring, this is a sample of the magnetorheological fluid. So I will pour this material into the measuring cylinder for sedimentation test. So this is These are the sample of my test for sedimentation of Magnetorheological fluid. After completing all the experiment, I have collected all the data, and right now I will use this equation to generate the values and to plot the graph. So for this sedimentation ratio, that is B over A plus B times 100%. Well, B is the cloudy fluid, A is the clear fluid. And for sedimentation percentage, X over Y times 100%, and this equation I will use for to find the sedimentation rate. Sedimentation rate. After that, the CD is coefficient, J-F coefficient, and RP is Reynolds number, and W, this W is dimensionless velocity. So I will use this to find the velocity of sedimentation of the magnetic particle. Sedimentation of magnetic particles. This is the raw data I have been collected, and this is the graph I have been plotted by using the equation just now mentioned above. And this is another graph. In conclusion, this final project consisted of objective which to identify the most effective material parameter and material properties in order to improve the sedimentation problem of magnetorheological fluid. So more experiment and research and testing and synthesizing of material is needed to ensure the sedimentation result and mechanical performance now and in the future.